Welcome back to MCP Training Series. In today's session topic, MCP Security and Best Practices. In this session, we're discussing one of the most important topics in AI development, security. If you're building with MCP, it's not just about making things smart, it's about making them safe. And trust me, MCP introduces some new security challenges that you won't find in traditional software. The Model Context Protocol unlocks powerful capabilities by allowing AI systems to interact with tools, APIs, and data. But with that power comes new risks like prompt injection, tool poisoning, and dynamic tool modification. These threats can lead to things like data exfiltration, privacy breaches, or even an AI system executing unintended actions, all because of something hidden in a prompt. The good news? You can absolutely defend against them, but it starts with understanding them. So let's walk through the most common risks one by one. Authentication and token management. Modern MCP implementations can delegate authentication to external identity providers, like OAuth 2.0 systems. This is a huge improvement over custom authentication servers. But even with this update, token mismanagement is a real concern. Some folks might be tempted to let the client pass its tokens straight to downstream resources, called token pass-through. This is explicitly forbidden in the MCP spec because it introduces massive problems. Clients can bypass critical security controls, it muddies the audit trail, and it can break trust boundaries between services. The bottom line? Only accept tokens issued specifically for your MCP server. Permissions and access control. MCP servers often get access to sensitive data, but if you're not careful, they might get too much access. For example, if your MCP server is meant to access sales data, it shouldn't be able to read all your enterprise files. Stick to the principle of least privilege. Use role-based access control, RBAC. Audit your roles and review them regularly. Implement granular permissions. Prompt injection attacks. One of the more AI-specific threats is indirect prompt injection. This happens when malicious instructions are hidden in external content like an email, web page, or PDF. When the AI reads that content, it interprets the hidden instructions and boom, unintended actions, leaked data, and potential harmful content, all because of something hidden in a prompt. A related attack is tool poisoning, where the metadata of an MCP tool is tampered with. Since LLMs rely on that metadata to decide which tools to call, attackers can sneak in dangerous behavior through tool descriptions or parameters. This is especially dangerous in hosted environments where tools can be changed after users approve them, a tactic known as a rug pull. Defense strategies. So what do you do about all of that? Here are key defensive measures. 1. Input validation and sanitization. Always validate inputs, check for malicious patterns, and sanitize data before processing. 2. Content filtering. Implement detection systems that can identify malicious inputs in documents and external content. 3. Data marking. Clearly distinguish between trusted system instructions and untrusted external content. 4. Sandboxing. Run tools in isolated environments to limit potential damage. 5. Audit logging. Track all tool executions and data access for security monitoring. Supply chain security. When building AI systems, your supply chain isn't just code. It includes models, embeddings, APIs, and context providers. Before integrating any component, verify its source, use secure deployment pipelines, scan for vulnerabilities, and monitor for changes continuously. Remember, MCP inherits your environment's existing security posture. So the stronger your overall setup, the safer your MCP implementation will be. Here are a few essentials to include. Follow secure coding practices, think OWASP Top 10 and OWASP for LLMs. Harden your servers with multi-factor authentication and regular patching. Enable comprehensive logging and monitoring. Design with zero trust architecture in mind. Key takeaway: MCP introduces new and unique security risks, but most of them can be addressed with the right controls and a strong security posture. The key is being proactive about security from day one, not treating it as an afterthought.